In this video I have some additional examples of how to calculate probabilities associated with the normal random variable using your calculator. Now, these are drawn from section 7.3, and I think you'd find it a lot easier to get something from the video if you're following along in the text. So do us both a favor and turn to page 402. We'll be taking some examples from there. If you're looking at the examples that they have written up in section 7.3, you might be thinking that the problems from that section are a lot more complicated than the ones that we saw in section 7.2. And if you're doing them by hand using the standard normal table, that's true, because you have to calculate a few more things. But if you're using a calculator like a TI-83 or a TI-84 to calculate these, it's pretty much the same thing. The first examples I'm going to do are skill builders. They don't really have any context, but here are the instructions. In problems 3 through 12, assume that the random variable x is normally distributed with a mean of mu equals 50 and a standard deviation of sigma equals 7. Compute the following probabilities. First up, we have number 4, which is asking for the probability that x is greater than 65. If you visualize this, it's a right-tailed problem, and the syntax for the normal CDF is lower limit, comma, upper limit, comma, mean, comma, standard deviation. So in this case, our lower limit would be 65. The upper limit would be positive infinity. We'll use the calculator's proxy for that, which is 1 times 10 to the 99. And then the mean is given to be 50, and the standard deviation 7. There's your result. Next up is number 6, which is asking for the probability that x is less than or equal to 58. Now that's a left-tailed problem. And again, the limits would be as follows. We need negative infinity as the lower limit. So we'll use negative 1 times 10 to the 99, which is the calculator's proxy. The upper limit would be 58. And again, the mean is 50, and the standard deviation would be 7. And there's your result. Next up is number 8, which is asking for the probability that x is between 56 and 68. Now, if I want it to be lazy, I can recycle my key sequence here, and I can just sort of selectively edit it. My lower limit here would be 56, and you can see I have some extra characters there, so I can just delete those. And my upper limit would be 68, so I'll change that to a 6, and everything else is the same. Press enter, and there we go. And then the last of the skill builder problems that I'm going to do here is number 14, and it says, in problems 13 to 16, assume that the random variable x is normally distributed with a mean of mu equals 50 and a standard deviation of sigma equals 7. Find each indicated percentile for x. Now, percentile, if you look up the definition, is the number at which whatever percent of the data is at or below. So in number 14, they're asking for the 90th percentile, which means they want the value at which 90% of the data is at or below. Below, in this case, meaning to the left of. So we're going to use inverse norm for this. And just like normal CDF, inverse norm can also work with a normal function that's not standard, meaning if you want to input the mean and the standard deviation, it's perfectly happy to work with that. So in this case, the region's area would be 0.9. That's the 90%, and the mean would be 50, and the standard deviation would be 7. And there's your x value right there, 58.97 and some change. Now the next example I have is one that involves a bit of context. Let's look at number 20 on the same page there, 402, and the problem says as follows. Wendy's drive-thru. Fast food restaurants spend quite a bit of time studying the amount of time cars spend in their drive-thrus. Certainly, the faster the cars get through the drive-thru, the more opportunity for making money. In 2007, QSR magazine studied drive-thru times for fast food restaurants, and Wendy's had the best time, with a mean time spent in the drive-thru of 138.5 seconds. Assuming drive-thru times are normally distributed with a standard deviation of 29 seconds, answer the following. Part A. What's the probability that a randomly selected car will get through the Wendy's drive-thru in less than 100 seconds? Well, it's very similar to the other examples we were doing. This is a left-tailed problem, and it's asking effectively what's the probability that x, random variable normally distributed representing time in the drive-thru, is less than 100, or less than or equal to 100. It actually doesn't matter. So we're going to use the normal CDF. And it's a left-tailed problem, so we need negative infinity as a lower limit. The upper limit would be 100. The mean is given to be 138.5. And the standard deviation is given to be 29. So there's your probability right there. Question B, or part B, is asking, what is the probability that a randomly selected car will spend more than 160 seconds in Wendy's drive-thru? Again, the lazy way to do this would be to reevaluate the same key sequence. We can just edit it. So I'll go back in here. And my lower limit in this case would be 160. My upper limit would be 1 times 10 to the 99. And it looks like I have an extra 9 or a 0 in there. Let me delete that. My mean is still 138.5, and my standard deviation is still 29, so I can just press enter, and there's the probability right there. Part C is asking, what proportion of cars spend between 2 and 3 minutes in Wendy's drive-thru? This is very similar to question number 8 that we just did. It's effectively asking, if you think about it, 2 minutes being 120 seconds and 3 minutes being 180 seconds, it's asking what's the probability that x is between 120 and 180. So I'll just recycle my key sequence again and go in and edit some of that. So we were saying the lower limit would be 120 seconds. The upper limit would be 180 seconds. And if you motor over here just a bit, you can see I have some extra characters there. I have a 9 that I don't need, so I'll just delete that. And then the rest is the same. There's the probability right there. So in terms of answering the question, they said what proportion, so it'd be 0.66 or 66%, 66.2%, depending on how you want to round it. And then finally, part D is asking, would it be unusual for a car to spend more than 3 minutes in Wendy's drive-thru? Why would that be? Well, 3 minutes would be 180 seconds. And so let's calculate the probability that x is greater than 180. Again, I'll recycle my key sequence. In this case, it's a left-tailed thing, so 180 would be my lower limit. And my upper limit would be 1 times 10 to the 99. Now I'm going to need to insert a character here. And if you arrow over to the left here, you can see that everything else is good. So press enter, and there's my result. Now when they ask if something is unusual, please recall they're asking, is the probability less than 0.05? And in this case it's not. So the answer is no, it's not unusual.